Hi everyone, my name is Ketan. I'm one of the TAs for the course Introduction to Deep Learning for Fall 2024. Welcome to Recitation 0L Dataloaders. So the purpose of this recitation is to understand the main concepts behind the PyTorch data loader. And we'll walk through a sample example of how to use the data loader itself. This notebook, we will cover what is the PyTorch data loader, how to initialize it, what is on-the-fly data loading. We'll see some of the different batching strategies, some customization as to how you can use the collate function. And lastly, we'll cover a couple of GPU and memory efficiency techniques. So where does the data loader come into play with respect to the model training workflow? So once we have the data, and as you guys will learn in lecture, you want to batch that data for more efficient memory usage as well as training runtime. And to do that, we can just loop through that data itself and iteratively slice the data into many batches. This is essentially what PyTorch does under the hood using the data loader object. Now we can see how the data loader object is actually used. Here is an example of a dataset class that has two lists, input and target. And inside this class, you can get the length of the input, which is corresponding to the length of the output. And you can also index the lists themselves. That's all this class is doing. Now let's see how we can use this class to create a data loader object. Here we can define our input as numbers ranging from 0 through 9, and our output is ranging from 0 to 20 by multiples of 2. Using that, we can either index the data set itself or use the getItem function as shown here. What's important to note here is the data loader object will just use this getItem function. Now, if we actually wrap the dataset in the data loader object, we see it prints out tuples corresponding to the XY pairs given as output from the getItem function. And as you can see here, every input maps directly to 2 times itself as output. A quick segue is on-the-fly data loading, which allows you to save some GPU memory by loading the data itself, not in the init function where you would normally load all the data, but rather in the getItem function. As in, you only load the data and take up the memory space when you're actually using that data in its specific batch. The rest of the data that's not in this batch is not taking up any memory space at the moment. Now, how can we batch the data using the data loader object? Here is a simple initialization of the data loader with a batch size of 4. And as you notice, before we had batch sizes of 1 here in this example, but here we have kept the batch size as 4. The input and the output that we're getting now each batch has 4 elements. And because we only have 10 numbers here, the last batch here consists of only 2 elements. Now we can do all sorts of things here, like we can also shuffle the dataset with the shuffle flag. And lastly, we can also drop the last batch to keep all the batch sizes same. Now we will walk through a sample example of how to put all of this together, creating a custom batch sampler. Here we just use the numbers with input being 0 through 9 and output being 0 through 18 by multiples of 2. So this simple dataset class groups the numbers based on whether it's odd or even. Here is an example of what our dataset looks like, where the first index corresponds to the enumeration of the data, and then this second index is actually telling us whether it's odd or even. Our custom batch sampler takes into account whether we are odd or even, or more generally, whether we are class A or class B. This can be extended to more than 2 classes, and based on that, we randomly pick a subset of the class that we care about. This is a pretty useful technique when we have data that's not normally distributed with respect to all of its classes. And by using this batch sampler, we can ensure that there's no inherent bias in our dataset and how we train the model. Now moving on to the collate function. The collate function is a special function that allows you to increase the customizability of the batching process. We can perform some dataset transformations in the collate function. And here is an example of that, where again we have the same input and target values, but now this collate function allows you to normalize the data by taking the mean and the standard deviation. And then you just normalize the numbers by subtracting the mean and dividing it by the standard deviation. And when we print out these normalized numbers, you can see these are the actual values and their corresponding target labels. And these are the customized or the normalized values associated with their target labels. That is the power of using a collate function. You can customize the data set as and when you see fit. Lastly, some GPU and memory efficiencies. So num workers here is an important parameter that the GPU uses to distribute the compute and the processing responsibilities. This will greatly enhance or speed up the runtime. So it's best to increase this as much as possible without throwing any error. However, once you do see an error, you should not go beyond that, as then the program may crash halfway through your run. And then the second one that we have here is the pin memory. When we use GPUs for training, data needs to be transferred from the CPU memory to GPU memory. Pin memory allows for fast and more efficient transfer between the CPU and your GPU. Now, when you set pin memory to true, you are ensuring that the data loaded by the data loader is stored in a page locked memory, also known as pinned memory. This can help in reducing the overall training time, especially when dealing with large data sets. So it's definitely worth checking out these two parameters when you are training your model for your homeworks. That was all from the data loader recitation. Thanks for watching.